yesterday, like this is a little peek intro at these concepts. We will spend all of chapter 5 working with these identities and much larger problems. So these are kind of just giving you a little introduction to the identities, how to use them, and how we could apply them. I would say number 65 out of the group of 4 that you were asked to transform was definitely the most interesting. So we have these 11 fundamental identities, which are just facts about trig functions. Number 65 gives us a wonderful problem that involves fractions, everybody's favorite thing to work with. So not only do you have to work with fractions, but you have to work with these sine and cosine problems in fractions. And you have to try and figure out what to do with them, because our goal is to transform one side. And this is the key. As I was looking at homework, you have to stick with a side and work with a side. You can't transform both. So we're going to work with the left side. In the end, when you are done and you've transformed it, your last statement for the left side should be exactly the same as what's on the right. So again, you cannot choose to do both sides. You got to pick one side, and we're going to work with the left side here. It's a little more involved than the right side. So our goal, the last sentence or equation, should say the left has been totally transformed to look identical to the right side. So in 65, it says the sine of theta divided by the cosine of theta plus the cosine of theta divided by the tangent of theta is equal to the cosecant times the secant. Now, this is an equation. Anytime there's an equal sign, it's an equation. An equation means equivalency. So that left side of the equation is equal to the right side of the equation. That's what an equal sign means. And I know this isn't an equation that you think of like 2x squared plus 5 equals 7x minus 4, but this is still an equation. We're asked to use identities to help us simplify this or transform the left side of the equation, but we're also going to have to use some algebra. So I saw some of you try and use the quotient identities because you know sine over cosine is tangent and cosine over sine is cotangent. So I saw some of you try and use that, which is great because you have to try something, you have to start somewhere. Unfortunately, that doesn't really do much to help us because this is a plus sign and our end goal is to make multiplication. And it's really hard to get a plus sign to magically change into multiplication. So we are not going to change these two using the quotient identities. Instead, we're going to try and use some algebra. So at the beginning of the year, we actually had fractions that we combined together. And I'm going to just get you to think a little bit algebraically. If you had 1 over x plus 1 over y, and you don't have to write this down, but this is just so you can kind of see the thought process. If that was your expression, and I said simplify this expression, Gabby, what would you usually do if you were trying to add 1 plus x over 1 plus y together?
Get them to have the least common denominator so you can add them.
Yeah, so they need to have the least common denominator so you can actually add them together. Gabby, if I had 1 over x plus 1 over y, what would the least common denominator be?
XY.
Yeah, xy. The least common denominator are the factors in each denominator. Well, x and y, they're by themselves, so they're each a factor. So x times y would become our least common denominator. So that's the algebra thinking. We're just going to apply that same thought process to having cosine and sine. So we want our denominator to say cosine and sine, or sine and cosine, however you want to say it. So we need our denominator to have both common pieces combined together. So we're going to make sure our denominator says sine times cosine. And I want the other one to also say sine times cosine. So we're using the least common denominator fact because a plus sign means we're supposed to add them together. And the way you add fractions is by having a least common denominator. So now we know what the denominator should be. Lucia, what would I multiply the fraction on the left by so that it has the least common denominator?
You would multiply it by sine.
Yeah. And whatever you do to the bottom, you need to do to the top. So Lucia, what does the top of this fraction become?
Sine squared.
Awesome. We write that little 2 next to the sign because it's just like x squared. The variable is squared. Well, the sine part is the function, and that's squared. We're not squaring the angle part. We're squaring the function. If we do the same thing to the other one, same thought process, there is a sine, so let's multiply it by its missing part, cosine. And again, cosine times cosine is cosine squared. So notice I didn't do anything to the right side of the equation because you're transforming one side. So we're really doing a little bit of algebra here to help transform. Once you have common denominators, you are allowed to add the numerators together to place them in one fraction. That's the goal of getting common denominators. So the goal of having common denominators is to have one fraction combined together instead of two separate. Well, to combine this fraction, we're just going to write them on the top of one fraction with a plus sign in between. So the only way I can combine them, they're not like terms, but I can at least write them on one fraction saying, now I have sine squared plus cosine squared in one fraction instead of two separate. So that was an algebra step, finding common denominators. If you look at what we have after we found common denominators, we now have one fraction. Is there an identity that involves something in that fraction that we can use? So let's take a peek at the identities. And here's our problem that we currently have. Is there an identity, Daniel, that we can use to try and help us change this left side?
Yes, sine squared plus cosine squared is equal to 1.
Yeah. So this whole top is 1. Substitution says we can take that out and replace it with what it's equivalent to. So the top becomes 1. The bottom is still sine times cosine. Nice, Daniel. So taking that whole top part out, substitution. If it's equal to something, you can take it out and replace it with whatever it's equal to. Daniel, question.
Yeah, I was wondering, there is another way to simplify that, which is dividing the top and bottom by sine cosine. So would that mean that sine plus cosine equals, sorry, oh, never mind. I read it wrong. I'm sorry.
Okay, you're good, but I'm glad you're thinking. And you'll see when we do more of these problems, Daniel, that there are going to be multiple ways to solve them. So sometimes there's one way, but once they get a little bigger and more involved, there's definitely going to be multiple ways. So the last part here that we have to work with is we have 1 divided by sine times cosine. Well, if I go back to my identities at the top, I have an identity that says 1 divided by sine is equal to cosecant. Well, I have 1 divided by sine. So that is the cosecant. And then there's another identity that says 1 divided by cosine is the secant. Well, I also have 1 divided by cosine. This fraction, oops, is the same as saying 1 over sine times 1 over cosine. Because the denominators are being multiplied. That 1 goes to both pieces of the denominator. So I can write it either way. But 1 divided by sine is cosecant, 1 divided by cosine is the secant. So again, please make sure, I know this is new to you, and I only introduced it to you yesterday, but please make sure that you're just picking one side of the equation. You can't change both. So I now have the cosecant times the secant equal to the cosecant times the secant. Questions? So good news, no, you're not going to see this on the test next week. The goal is to introduce you to the identities and to get you familiar with the identities. So you will not have a problem like this on the test. There are 2 problems on today's worksheet, review worksheet, just to get you to practice more, but this is truly an introduction. We will do more of this as we move forward in trig. Any questions? The other problem that was on the homework questions form was, actually it says geometry here, so this is question 77. This is one of the 2 problems that you had to draw your own diagram. So the last 2, 77 and 78, you had to draw your own picture where the other ones were given for you. A 6-foot person walks from the base of a streetlight directly toward the tip of the shadow cast from the streetlight, or by the streetlight. When the person is 16 feet from the street light and 5 feet from the tip of the streetlight shadow, the person's shadow starts to appear beyond the streetlight shadow. Draw a right triangle that gives a visual representation of the problem. Show the known quantities and use a variable to indicate the height of the streetlight. All right, so let's see if we can draw this. Read through it once, now we're going to try and make a little picture. We know we have a streetlight somewhere. So make yourself a streetlight. Most times they're vertical. And then we have a person who's currently right next to the streetlight, but he starts walking from the base of the streetlight. So my little point represents where the person is, and he's going to start walking from the base of the streetlight. It says when the person is 16 feet from the streetlight and 5 feet from the tip of the shadow, his shadow starts to appear. So right now, the person is standing 16 feet from the streetlight and 5 feet from the tip of the shadow. So I can also label that information. 16 feet from the base, 5 feet from the tip of the shadow. So he's kind of somewhere in between right now. We want to draw a right triangle that gives a visual representation of the problem. So we don't have a triangle quite yet, but if I go to the tip of the shadow and I form a right triangle, now I can see that I do have a right triangle drawn. I'm going to take out my little person guy and also make that a straight line. So this is our little person here. So it wants us to show the known quantities and use a variable to indicate the height of the street light. So I like using H for height, but you don't have to. I'm going to label that as H. Is there anything else we can label in this diagram? So label the known quantities. What else can we label in this diagram?
The height of the person, which is 6 feet.
Yeah, and I think that was the first thing that was said to us. So that was a big paragraph, and you maybe have missed that part. But the person is 6 feet tall. So we can label that height of the person. So now we have this big, nice triangle drawn. We've got the person that is somewhere from the street light to the tip, 16 feet away from the base of the street light. There are 3 different ways that you could think about solving this problem. It does say that it's a geometry problem, which, I mean, that might be a good idea. And it said to label the known quantities and then the height of the streetlight. So we have a variable to represent that. If you look at this diagram, there are actually 2 triangles in this diagram. There's the triangle down here at the base, a tiny little triangle. It's kind of like a secondary triangle that's made. And then there's the triangle of the whole thing, the street light to the tip and that entire base. If you go back in your brain and think about geometry, if you have a small triangle and a bigger triangle, they're both right triangles. Does anybody know the name of those triangles? Daniel?
They're similar.
They're similar triangles. What can you do if you have similar triangles, Daniel?
Their sides are proportional.
Yeah, similar triangles are
Um,
proportional. So how could I use that to make an equation?
Well, you could say that 21, the base of the big triangle, was to 5 as 6. Sorry, as the height of the big triangle was to 6. So,
Yeah,
yeah.
perfect. So you can make a proportion. A proportion is two ratios, fractions set equal to each other, comparing sides of the triangle. So you can compare the base, the entire base of the whole triangle to the base of the little triangle. And we can compare the height of the whole triangle to the height of the little triangle. So that's one way I could solve for h. Another way I could solve for h was to say, hey, there's really a little angle down here. And that little angle, if I look at the entire big triangle, would be represented by tangent because the height is the opposite and the base is 21. If I go use the smaller triangle, this little triangle here, I know the tangent of this little triangle is 6/5. So I could take the tangent and say, well, tangent is really 6/5 from the small triangle, and I can set that to h/21 from the big triangle. Either way, you are going to get the same exact answer. It just depends on how you think about it. There's actually a third way that you could calculate this, and you could find the actual angle by using the inverse tangent, and then you could take that answer and set it equal to h/21. So you could use pure straightforward geometry, or you could use the trig function of tangent and the fact that you have the opposite and the hypotenuse and set up an equation that way as well. Questions? As the homework I was looking at, most of you did it one of those two ways. A few of you found the angle as well. But that would be two different ways to think about it. Any questions? So I'd like you to go to Google Classroom. In Google Classroom should be the worksheet posted, the review worksheet for today. I just want to show it to you so you have an idea of what you're looking at. It does go in order of the concepts that we've talked about in sections 4.1 through 4.3. So it is in order. Some of these questions should be really quick. You know, most of these don't take a lot of work, but I need to see something showing how you're thinking about that solution. So you show me something to receive credit. So the first page here is section 4.1. So it starts off with drawing an angle, 3 coterminal angles, complementary, supplementary, converting. And then the last 2 questions deal with finding a central angle if you're given a radius and an arc. And I have that information labeled here. Number 10 says you're finding a radius R, they give you an angle, they give you the arc. So anytime you have an arc, you have a radius, you have a central angle, I have the 2 formulas written. Just depends on what we're trying to find or think about. But the key thing is the angle is in radian measure when you're using those formulas, because it's the formula for radian measure. So the angle that you find will be in radian measure, but if you're using an angle, it has to be in radian measure. So 1 through 10, all of section 4.1. Number 11 starts section 4.2. This section is when we talked about the unit circle. 4.1 was kind of introducing you to terms in trig and types of angles that we can find in trig. So number 11 says sketch the angle and find the point that corresponds to the real number t equals 4/3 pi, or 4 pi over 3, however you want to say it. So draw a little diagram. Sketch the angle. I know that the denominator is thirds, so my numerator has to be divided up into thirds, or the top of the circle is thirds, the bottom of the circle is thirds. And then I need to go to where it's 4 pi over 3. So that's sketching the angle. And then you're finding the point on the unit circle that corresponds with 4 pi over 3. So think about those ordered pairs that correspond with the angle. So you're going to do that for 11 and 12. And really, you're going to do that for 13 and 14 and 15. The questions are just slightly phrased differently. In 13, you're going to use the point to find the tangent. In 14, you're going to use the point to find the cosine. And in 15, you'll use the point to find all of the trig functions. Number 16 is pretty much the same as all of the problems above, except 16, all the angles that are given are acute angles. So if you get in the habit, and some of you are already in the habit, of on your homework, writing down the ordered pairs that correspond with each of the angles, it might help you as you're working through problems. But pi over 6 is the same thing as 30 degrees. Pi over 4 is 45 degrees. Pi over 3 is 60 degrees. And those ordered pairs on the unit circle, I've seen some of you writing them on some of the homework so that you have them to kind of look at and apply. So Sadie, if I have an ordered pair on the unit circle, do you remember which function represents the x in that ordered pair, sine, cosine, tangent?
The cosine.
And then the y would be?
Sine.
The sine. So I can answer a whole bunch of questions on this page, pretty much 11 through 16, using those ordered pairs, because that's all you need. You need those 3 ordered pairs, and all those ordered pairs go with most of the angles given on this page. Number 17 is what we talked about yesterday. So this is giving you, it says you have a right triangle. And it gives you the cosine is 5 over 7. If you have a triangle and they give you the cosine being 5 over 7, what sides of the triangle could we label if cosine is 5 over 7?
The side next to the angle and the hypotenuse.
Yeah, so pick an angle wherever you want it to be. The side next to it is the adjacent, and then the hypotenuse. So it says the third side of the triangle, so you need to find that third side. That's what we want to find. And then after you find it, you're going to find the other functions that are listed underneath. Number 18 is the identities that we were just talking about. So letter A, you're going to use an identity to change the right side. Letter B, you're going to FOIL first and then use an identity. And then 19 and 20 are more triangle problems. And I actually have, I guess it looks like 21. I didn't erase. I drew the little diagram again for 21, but it's a lot sloppier. Those last 2 problems are problems that we talked about the last 2 days in class as well. So I'm going to stop talking. I'm going to open up the quiz for you on Google Classroom. I want you to remain on Zoom with me. The quiz should take you about 5-6 minutes. It's 5 questions. So if you go to your Google Classroom, the quiz is not there yet, but it'll be there momentarily. I just need to open it and assign it to you. Uh-oh. Well, maybe not.
Miss Kane, I can see the quiz.
Can you see it? Okay, good. It must have popped up just as I was going. All right, good. Thank you for letting me know. I must have done it as I was going over there. So if you want to open up your quiz, you'll see that there are 5 questions on it. There we go. And just to kind of explain the last 2 problems, if you want to draw a triangle, you can, but you don't have to. If you want to use what we just talked about with the unit circle, you can use that as well. But your goal is to figure out what the value is, what it's equal to. I don't want to know that pi over 4 is a 45-degree angle. What is the sine of pi over 4 equal to? Or what is the cosine of pi over 4 equal to? So that's what you're finding for 4 and 5. If you have questions, feel free to ask. Send it to me in the chat. 5 little questions. The first 3 are worth 2 points. And then 4 and 5 are just a point.